Okay, so we don't have a super large amount of things to get through today, nor are the things that we have to get through terribly lengthy. Uh, but I think you'll like at least the second thing to watch. The first one is a refresher on 5 CSS properties that almost nobody knows. Okay, I'm going to put up on Canvas. Learn. I think the CSS one is like learn CSS in 20 minutes or something. The other two, one is learn HTML in an hour, and the other one is learn JavaScript in an hour. Now you don't have to watch those. If you think you've got those three down decently at least, you don't have to watch them. I'm providing those to you because of the final you have coming up, or excuse me, the midterm you have coming up next week. I just want you to make sure that you're refreshed and that you know everything. I've got 3 PDFs I'm going to upload, which are Chrome keyboard shortcuts that should assist you in your development of the web. Now, the first video, like I said, is 5 CSS properties that almost nobody knows, and the other thing we're going to watch is about 30 minutes, and it is using the Web Audio API to build a guitar amp out of your computer. Okay. I would love to see somebody take this concept and build a guitar tuner into it as well. That'd be really neat if you had a little feature on your website that like, oh, you can tune your guitar here. Oh, you can turn your guitar up and down and that sort of thing. Now, show of hands, other than Kyle, anybody here play the guitar or any other instrument? No? Okay. Don't worry about that. Not a big deal. Might be kind of a big deal if you were building a guitar tuner maybe, but this is just volume, bass, mid, and treble, and then it has a visualizer that represents the sounds as they come through the computer. You could also use this same concept if you maybe wanted to get a song, and on your website, when you load it up, it has a little visualization of some sound that's playing, and then click a button to go into your site and things like that. Does anyone know DJ Peace out of Arkansas? I did a site opening for him several years back for his site that was basically that same thing. I use After Effects to do it, but it was the same principle. Okay, so without further ado, let's watch the 5 CSS properties that that almost nobody knows, excuse me, and then we will figure out how to use the Web Audio API. So let's hop over here real quick.
In this video, I'm going to be covering 5 really cool and unique CSS tips and tricks, and I bet that you don't know all of them. So let me know down in the comments below how many of these that you actually knew before watching this video. Let's get started now. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Also, if you want to take your CSS skills to the next level, check out my full CSS course linked in the description below. So to get started, I have some really simple HTML and CSS. We have this card class, which wraps a header and a body, and they both just have some placeholder text. And then our card is just having a set width, background color white, border that's black, as you can see on the right. Our header is that blue section at the top, and then our body just has a little bit of padding. So we have essentially a card design here. And for this card, I actually want to make it so that this header, if it's longer than one line, it'll just have the little ellipse at the end, so the triple dots at the end, saying that it's longer than one line, and it won't actually wrap like this. And luckily, in CSS, there's a property called text overflow, which allows us to do exactly this. By default, it's set to clip, which means it just clips off all the text that expands past the element. You've probably seen this before. And ellipsis is where you have those triple dots at the end. And if we save this, you're going to notice it really actually doesn't do anything right away, and that's because this only causes the text to have these ellipses at the end if it overflows the container on the horizontal axis, so it comes out the side of the card. If it's too tall, it won't actually cause this overflow because this is only for the horizontal axis. And the way that we can make it so that this text overflows is by just preventing it from wrapping. So we could just say that we want to do white space, and we want to set that to no wrap. That means that the white space is not going to wrap onto a new line. And now if we save, you can see our header has expanded past our entire screen. It's overflowing its container, but it still doesn't have those ellipses. The final thing we need to do is tell our CSS to hide the overflow. So if we set overflow to hidden and save, you can now see there's no text expanding past our screen, and we have the ellipses at the end of our text since it's overflowed its container. If our text was much shorter though, such as just a lorem, you can see there's no ellipse at the end, and that's because it's not actually overflowing anything. So the important thing to know about this text overflow property, it's very commonly misused because you need to make sure that it's only in this horizontal axis. It has to be one line essentially. And you need to make sure that your white space is set to no wrap and your overflow is set to hidden, essentially making sure all your text is on one line and that the overflow is hidden, which is what causes the ellipses to show up. Now, the second property that I want to talk about is text shadow. Essentially, when you've used box shadow on boxes, text shadow is the exact same thing, but for text. So we could add a shadow to our lorem ipsum text, which is just this h1 down here. We could just say text shadow, and this is going to have the exact same syntax as box shadow, except for it doesn't have a spread value. So we have our X and Y offset, which we're just going to set to 0 here, and then we have our blur for how much the shadow spreads out. Let's just set it to 1 pixel, for example, and we're going to set our color to red. Now if we save, and we actually just bump this up a little bit to 10 pixels, you'll notice we have this nice 10 pixel glow to our elements, so we can add a shadow or a glow to all of our text. We could even take this a step further. For example, I could make this offset like negative 20 pixels. And now you can see we kind of have our text showing up behind our text. That's kind of a cool effect that we can do. We can reduce our blur down and it looks like our text is more solid. So now we have like our exact text showing up. We could even reduce this down to 0 and then there's no blur at all. So it's just like a copied version of our text essentially, just offset by 20 pixels. So if we just did like 5 pixels and 5 pixels, it kind of gives us a cool like drop shadowy technique that we can use for all of our text. So text shadow is really useful, super underutilized because I really don't see it anywhere, and it can give you some really cool CSS effects that are way harder to do if you try to do it without text shadow. Now the next really cool effect that I want to look at is actually going to use the same text. So let's just remove our text shadow. And this is essentially if you want to put something behind your text, such as an image or a video, and make it play through the text, it gives you kind of a really cool effect with your text. So to do that, it's actually really straightforward, especially with an image. I just have this water.jpg, it's just a picture of water that we're going to put behind our text. So we can just say our h1 is going to have a background image, and it's just going to be the URL to water.jpg. And if we save, you can now see we have that water showing up behind our text. But clearly this is not what we want. We want our text to be the only thing where this water picture shows through. So what we can do is use a really cool property called background clip. We can set this to text. And you may actually notice when I save this, it doesn't actually change the text on the right. And that's because in Chrome, background clip is only accessible if you do it with the WebKit prefix. In Firefox, for example, this is already working without the prefix, but in Chrome, you need to use the prefix. Now if we save, you're going to notice something interesting. Our background, looks like it just completely disappeared. And the reason for that is that our background is only showing up behind our text, but our text is black. So if we change the text color to be transparent and save, you can now see the image is showing through only where our text is. And if we just change the background of our body, for example, background to like black or something, it's a lot easier to see this water showing through. We could even change it to like red, and that should be really obvious where our water is showing up. Obviously, this image is not really that good for what we're trying to do, but if you have a larger image and a larger section of text you want to show it through, this could be a really cool way to make your text just pop a little bit more by having an image show up in the background. And like I said, if you're in Chrome, you need to have this prefixed. So generally, what you would want to do is write something like this. That way, if it's in a browser like Chrome, it'll fall back to this WebKit version. Otherwise, in something like Firefox, it'll just use this proper background clip version. So that's what you want to do if you want to put an image or video or something behind your text. Now we can just stick with this same text here for our next set, and this is going to be a really simple property that allows you to access literally every single CSS property on an element. If you want to reset an element or change something about an element, you can use the all property. So if we just select our h1 again down here, and we said like all is initial and save, you're going to notice all of the styles for our h1 have been changed. Everything inside of here has been set to initial. So it's got all these fallback values being set, and it's just some normal text showing up on our screen. This is really useful if you want to reset values or undo values or just essentially undo everything that is done to something. You can say all initial and then do the rest of your style. So for example, we could say font size is 3rem. Now you can see that our font size is 3rem because we reset everything and then change the font size. This is really useful, especially if you're importing a library or something that makes changes to some styles and you just want to wipe all of the default styles they apply. All initial is a great way to do that. Now for our final unique CSS property, this is probably one that you used all the time, but you may not be exactly familiar with how it works. And this is the border radius property, because depending on how you set values for a border radius, you may get an ellipse shape or you may get a pill shape. So understanding how to use border radius correctly is great because it means you're always going to get the shape that you want. So for example, you know that if you create a circle inside of border radius, all you need to do is do border radius of 50%. This is going to give you a perfect circle. And this is great if you have a perfectly circular object. But when you have something that's not a circle, such as this rectangle here, and you save this, and I make sure I change my class name to have the correct capitalization, you'll see that we get an ellipse shape because it's trying to give our border a 50% radius on all sides, which creates a circle because it's rounded all the way around. Generally, this is not a shape that we actually want though. Instead, we'd rather have a pill shape where it just rounds itself on the edges and is straight all the way until it rounds itself on the edge again, because this ellipse shape is really not that good looking. So to get a pill shape, you normally would say border radius, and then you would have to know the height of your button. So if our height, for example, was 50 pixels, we could come in here and say border radius 25 pixels, and that's going to give us our pill shape. But knowing that ahead of time kind of sucks. So if we don't know our height and we set our border radius, we just need to set it to any pixel value that's greater than half the height. So generally, if I want a pill, I'll just set the border radius to 9,999. That way I know this is always going to be larger than half the height of my element, and it's going to give me a pill shape perfectly. But when you use percentages, such as 50%, it's going to give you this ellipse shape. So knowing the difference between the two and when to use which one is really useful. And those are my 5 unique CSS properties. Did you know?
Okay, so couple of things. First thing, you may have heard me mention important before, exclamation point important, right? Which overrides styles, which you typically use in a situation where you may not have direct access to the CSS. But you have like if you're editing someone's WordPress site for them and they don't give you, they're just hosting it on like GoDaddy or something. They don't have like maybe direct FTP access. I mean, with GoDaddy you would, but they don't have direct access to the actual CSS files for the WordPress site. You can actually go into the like site editor and use important to say this code I'm getting ready to write, the CSS I'm getting ready to write, use it instead of whatever is the default. That all initial is the same thing and really a better way of doing it, because if you use important too much, you can actually confuse the browser. Whereas the other thing is similar to using an asterisk to reset all of your HTML, right? The other thing is knowing how border radius works is really important when it comes to mobile app development. Does anybody want to guess why? Using specifically the example that he gave with the pill and the ellipse, you may want to guess why. Okay, so when you're using percent values, which you normally use when you're doing mobile app development, because you don't want to use pixels because different screen sizes have different pixels, right? That's an example when you do want to use pixels to get those nice little mobile buttons, right? That have that nice little pill shape or something similar. If you use percentages, as he demonstrated, you get ovals. Okay, so just bear that in mind. If you want pills, you want to use pixels. If you want ovals, you want to use percentages. Okay, and that's the case regardless of whether you're doing mobile app or regular web development, right? You should always use EMs and things like that, proportional things as opposed to pixels, except in that one instance. Okay. All right, so let's move on and let's watch our video. So go ahead and fire up brackets if you so desire. Now remember, I mentioned that you don't need to be able to play the guitar to do this. Literally all we are doing is we're using different web APIs and things like that. So I'm basically just trying to kill a couple of minutes while we're getting everything set up. But anyway, like I said earlier, we're talking about sliders. So when you have like a button, you can slide it back and forth, right? We're going to talk about visualization. We're going to talk about the web API or the web audio API in general. You may not be aware of this. I think I mentioned this in Web Dev 1, but you may not recall, and I also may not have mentioned it, although I think I did, that Web 2.0, I'm going to do the quotation marks here, so like HTML5 and like all like the most recent standards for HTML support the video and audio tags, right? So that I can embed a video directly into my website. I don't have to like embed it from YouTube or something. If I want to host it directly on my website and then embed it in a page, I can do that. Same kind of concept with the audio API, and one of the cool things that comes along with both of those is the ability to manipulate video and audio as well. You get various controls. So like for example, with the video one, you can tell if you want it to have controls or not. You can tell if you want it to be full screen or not. If you want them to be able to change the quality. You can add download links, I believe, if I'm not mistaken. There's all kinds of cool stuff that you can do. So this is the audio one. We'll get to the video one here before too long. I've got a couple other fun projects I want us to do before that, but we'll get to talking about the video API a little bit going forward. So without further ado, let's hop over here and learn how to use the web audio API to play the guitar. Now, like I said, it's only a 30-minute video, but as always, if you have questions or need me to stop, go back, pause, anything like that, please raise your hand and let me know, and I am more than happy to do that, okay? Really quickly, something I wanted to mention, hearing him play that made me think of this. I was reading a thing the other day that was saying that like even 2 seconds of a popular song played by you can get you a copyright strike on YouTube now because of the auto content ID thing. So like people that will say like, so I'm gonna like play all these different guitar solos and like compare them and talk about them and construct them and break them down, which should be considered fair use. YouTube is now taking people's stuff. So like one guy said the words, didn't sing it. He said the words "living on a prayer," and they took his video down. It's a copyright claim, like copyright infringement. So how in the world this video is up, I have the faintest idea. He must have like bought the rights to be able to cover it or something like that. It's the only thing I can think of. Sorry, I just wanted to mention that because I literally just read that. I got a copyright strike on a video from Friday's class, on the lecture video. Apparently I used a Coldplay song. You remember me playing a Coldplay song that day? Yeah, no, because I didn't. But apparently Warner Music thinks that I played a Coldplay song in class. So if you live in certain countries, you can't watch that video, which doesn't affect us, but it's the principle of the matter, right? So anyway, sorry. Just wanted to bring that up.
Could be because it's a fairly old video.
Could be. Yeah, that it's not like going through looking at old stuff. Yeah, that could be. That could be. It's a good point.
Have you ever had a non-technical client or manager review your website only to give you feedback such as, "I clicked the button and it broke"? This just devolves into a long email. For sponsoring this video, make sure to learn that, so don't make fun of it. Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Now in the intro you saw me playing the beginning of Sweet Child of Mine. I'm just starting to learn that, so don't make fun of my terrible music ability because I have a long ways to go. But you'll notice that we had this visualizer to go along with it. We also had these different controls where we could change the bass, the mid, the treble, as well as the overall volume. And in this video, I'm going to show you exactly how to make this. And right now you'll notice that the visualizer is actually picking up my voice through my microphone. When you watch back the edited version of my video though, I'm not going to be using the output from this application. So if I change the mids, for example, or if I change the bass, it's not actually going to modify the sound of my microphone. It's only going to modify the sound of my guitar, but they both go through the same interface in my computer, which is why right now you're seeing it here. But I'm going to edit that out so you don't have to listen to my voice when we change around all these different controls. Okay, now with that all out of the way, let's just get started with a simple index.html file, and then we're going to need a script.js file, because this is going to be all front-end work, and it's actually a lot easier than you would think. So in this index.html, if we hit exclamation point and tab, that's Emmet is just going to generate this boilerplate for us. And if you're interested in how that actually works, I have an entire tutorial on it. I'll link in the cards and the description down below. Now the next thing we're going to do is just link up that script.js file. Make sure we add the defer attribute so it loads after our body, and that's pretty much everything we need up here. Now we can work on the content of our application, and it's going to be fairly straightforward HTML. I wanted to make the styling minimal so that way you could make it as cool and styled as you want and really take this application to the next level. It's more so about the JavaScript, so this section is going to be pretty straightforward. The first thing we need is a canvas, which we're just going to give an ID of visualizer. And this is essentially this visualizer down here at the bottom that you see. This is what the canvas is going to be controlling. Now the next thing.
Now I'm going to voluntarily pause here real quick. We haven't talked about the canvas yet, okay? But going forward, especially with one of the projects that I have, we might get into that next week or either midterms week or the week after, where we're going to actually make a snake game, okay? We're going to start getting into the idea of like interactivity. More than we have been. And with that comes the canvas. Now, you don't have to use the canvas, okay? And if you'd like to do some research in between now and then about what the canvas is, I'll cover it in class, but if you want to do some research ahead of time, it just makes doing things easier. That's an HTML5 and up feature. That's one of those like fancy Web 2.0 features I was talking about. That lets us do a bunch of really cool stuff. And in fact, if you make like a game in Unity and you export it to HTML, it puts it onto a canvas. So HTML games are pretty much entirely done via the canvas. Again, you don't have to use the canvas, but you have to use the canvas. Does that make sense? Like it's just easier and considered a best practice to do so.
What we're going to need is a grid. And this one is going to have a class. We're just going to call it grid here. So we have a div with the class of grid. And this is what's going to contain all of our controls up here. So let's just create these different controls. Whoops. We're going to have a label. And this label is going to be for our volume. Just like that. And we're just going to say volume in here. Whoops, volume. And then we're going to have an input associated to that. So we can say input, and this is going to be a range input. And this input is not going to worry about the name. We don't really need that, but it is going to have an ID of volume. That way it matches up with our volume label here. I also want to make sure I put some min and max values on here. So the minimum value is obviously going to be 0, no volume at all. Our maximum is going to be 1 because this is decimal based, so that's like 100%. And then our default value is just going to be 0.5. And we want this to be a step here. Whoops, step, which is just 0.01. So it's going to change by 1% at a time when we move our little scroll bar. Now, if we just save this, open it up with live server, it's going to pop up on the right-hand side here in just a second. And there you go. We see now we have this volume knob that we can change. And now let's get all of our other knobs in here. So let's just copy this real quick. Our next one, if we go back to this page over here, is going to be for base. So let's just change this all around to be associated with base. It's going to be a range input. We're going to have volume here. And what this is doing is instead of turning the bass on or off, what it's really doing is adjusting the loudness of the bass. So we're reducing and increasing the number of decibels essentially of our bass frequencies. So instead of a min of 0, that would be like no modification at all. We want our min to be -10. So this is going to reduce the decibels of all the bass tones by 10 dB. For the max, we're just going to have +10. Our value here is going to be 0. And we're just going to delete this step because by default, it has a step of 1. So we're going to be changing by 1 dB at a time. Now, if we save, come over here, we now have our bass slider right here and our volume slider. Now let's get some more sliders in here. We can copy this down 2 more times because we're going to have our mids. So let's just make sure we have mid and treble. I'm going to say mid and treble. And here we're going to have mid and treble. So now if we come over here, we should have all of our different sliders. It's obviously not looking very good right now. So the next step is to get it centered in the top like this. And that's actually fairly straightforward. We're just going to do some styles here because we don't really have very many we need. The first, I'm going to style our body. Now for the body, all I want to do is change our background color. So we're just going to come in here with a background color and we're just going to do this DB color, kind of this nicest gray color that you can see here. It looks pretty good. Now the next thing I want to work on is that grid that we created. So we'll just say .grid. And this grid is of course going to be a display of grid. And our grid.
Okay, super quick. Anybody want to guess why he doesn't have a style sheet linked to this? Why he's doing the thing I told you to never do and doing inline styling? Yeah, yeah. Now you may recall in WebDev 1, I talked about that. Well, I say this in a lot of classes, but I definitely said it in WebDev 1. The idea that like there are all these rules and best practices and like don't ever do this except when you have to, right? And I always use the analogy of when you like in Half-Life 2, right before you go to Ravenholm, when you get the gravity gun like out back behind like the research facility, Alex like looks down the hallway that leads to Ravenholm and she's like, that leads to Ravenholm. We don't go there anymore. And anytime that I play that game and she says that line, I always respond with, yeah, except for when we do go to Ravenholm, because it's like the next thing you're getting ready to do is like go there, right? Um, that's kind of what we're talking about here, right? If you just need like all I'm going to do is like do a background color, tweak a couple of grid settings, maybe change the font or something. If you have less than I feel like if you have less than 5 stylable elements on a page and you are using 5 or less attributes on each of them, there's really no reason to have an external style sheet, especially if you only have a singular page. Really, where style sheets come into play is if I have multiple pages that I want to style all the same. It's kind of like how if I wanted to bold a word in the middle of like if I created my own blog system, let's say, and I'm typing a post out and I'm like I want this word to be bolded and italicized, people really know that I put a lot of emphasis on it. Yeah, I could make a style rule for that, or I could just use a little bit of literal inline styling, right? That's not really, it's embedded styling, it's not really inline, but I could say like strong around that, just like that one word. Now, best practice, and I'm doing it for people that aren't in class right now, that I'm doing the quotation fingers, the best practice for that is to not do it that way, right? Is they would say, no, create a style rule. But what kind of sense does that really make? For this one instance that I'm using this thing, why make a whole style rule for it, right? Does that make sense? Okay, let's move on.
Grid template columns, we come over here, we just have 2 columns. And the first column is going to be auto size. It's essentially going to be as small as it can possibly be. And same with this, we're going to set this to min content, because if we set it to auto, it'll fill like the entire width. Min content is going to make it as small as humanly possible. And just with that, we now have our 2-column layout set up. But you notice everything is kind of stretched out. So to fix that, we can just justify our content in the center, and we can justify our items on the end. So now if we save, you're going to notice that immediately is pushing everything to the center, and it's lining all of our words up on the right hand side. That's what this justify items is doing. It's moving them from left aligned to right aligned, which looks a lot better. And then lastly, we can align our items in the center, and this is just going to make it so that our text and our range input here are kind of lined up vertically in the same orientation. That just looks a little bit better. And now the reason right now this is pushed down so far is because we have this big canvas element up here. So let's select our canvas element. And what we're going to want to do is we're going to change the position to absolute. We're going to change the top to 0, the left to 0, the width to be 100 view width, and the height to be 100 view height. We essentially want our canvas to fill up our entire page. So now our canvas is all of this space. It fills our entire page up. And the last thing we want to do is right now we can't change our inputs because our canvas is over top of it. So what we can do with our canvas is we can change the z index to -1. That's going to put it behind everything. And we can set the pointer events to none, so that way essentially our mouse does not interact with the canvas, because we don't want to interact with this. It's like a background element, it's not really a foreground element. Now the last thing that we need to do on our grid here is add a little bit of spacing, because it is super crunched together. So we're going to set a gap of 5 pixels and 10 pixels. That gives us a little bit of space. And then on our input, we're going to get rid of the margin that's on there by default. So we're just going to say margin of 0. That makes everything look a little bit better in my opinion. Like I said, it's not beautiful, but it's good enough for what we're doing. And the whole point of this app is to focus on the JavaScript, which is what we're going to be doing right now. So the very first thing that I want to do in here is to get all of these different elements. We have IDs on a lot of these, our visualizer, our volume, for example, our base, all that stuff. Let's just get all those elements. We're going to do volume first. That's going to be equal to document.getElement by ID of volume. I'm going to copy this down a couple times because we're going to have base, our mid, and we're finally going to have our treble.
Okay, you're saying to get that all typed out or copied or whatever you choose to do. Okay, let's move on.
And this is just going to be here, bass, mid, and treble. And then we're also going to have our visualizer. So we're going to say visualizer is equal to document.getElement by ID of visualizer. And let's just make sure we spell that correctly. And there we go. We now essentially selected all of our elements. We haven't done anything with them, but we have access to them, which is exactly what we want. And now we can get on to the fun part, which is going to be actually integrating our audio into this. So let me just close out of our old application so we don't have any interference with that. And the next thing I want to do is to create what's called an audio context. So we can just say new audio context. And this audio context is essentially where we're going to control everything about our audio. We're going to change our volume through here, our bass, our mids, our treble. We're going to integrate the guitar into here, which will also integrate my microphone as well. And we can handle all of that and so much more through this audio context. So to get started, all we need to do is connect the input that we have, in our case, our guitar, into this audio context. So let's create a function for doing that. We'll say a function which is going to be called getGuitar. That's going to get our audio source. And we're also going to create another function which is just going to be called setupContext. And this setupContext function is where we're going to integrate our guitar, and getGuitar is where we're going to get access to it. And this getGuitar function is going to be really simple. We just want to say navigator.getUserMedia, and we want to get an audio source. So we can just come in here and say audio, audio. And normally you would just set that to true if you want to get your, normal audio source. But one problem with this is that some of the browsers actually do extra work to clean up your audio for, voice speaking. But when you have an instrument, you don't want any of that extra cleanup. So we're going to turn all of that off. So echo cancellation, we're going to set that to false. We're going to set our auto gain control to false. We're going to set our noise suppression to false. And also we're going to set the latency to 0 to give us the most real-time experience of playing our guitar and hearing it out of our speakers. And again, you can do this with your voice to create like a voice changer app if you don't have an instrument on hand. So now this getGuitar function is completely done, and inside of our setup context, we can actually use that guitar. So we can just say const guitar is equal to, and we need to await this because this returns a promise. So we're going to await that promise, and we're going to call getGuitar. So to use async await, we need this to be an async function. And if you're not familiar with async await, I have an entire video on it. I'm going to link in the cards and the description below. So now with that done, we have our guitar, and we can actually integrate this into our context. And to do that, we need to create a source. So we can say const source, this is going to be essentially our audio source for our context, is equal to context.createMedia stream source. Whoops, not destination. Media stream source. And we just pass in here our stream, which in our case is this guitar here, because this is returning us an audio stream, and we're just creating a stream from this. And now we're getting returned a source. And with that, we can just say source.connect, and we need to connect this essentially to our output, which in our case is our context.destination. That's going to essentially be the speaker for your computer. So now all that's left to do is just to call that setupContext function. Now if we save, come over here, you'll notice nothing's actually working. I can play the string on my guitar, and you won't hear anything coming through. And the reason for that is if we inspect our page, go to our console, it says failed to execute getUserMedia on Navigator, 3 arguments required, but only 1 present. So if you see this error, what you need to do is this should be navigator.mediadevices.getUserMedia. Now when we save this, come over here, it's going to ask us to use our microphone. We'll just click allow. And if we inspect, you might see an error in the console that says something along the lines of could not set up audio context. If I refresh, we might see this. There we go. The audio context was not allowed to start. It must be resumed or created after a user gesture on the page. This essentially means that when a user goes to a page, they must interact with it first before you start up this audio context and start playing your audio. So to get around this issue, what we can do is before we set up our source or anything like that, all we need to do is have a simple if check to see if our context is started. So we can say context.state is equal to suspended. If this is true, then that means our context is currently not playing. And all we want to do is await context.resume. So this is going to try to start up our context, so as soon as someone interacts with our page, it'll essentially start the context for us. And now if we go to inspect, you can see that we no longer have that error. And hopefully when I play my guitar string over here, we should actually hear noises being played. So now instead of tackling the easier task of doing these volume and bass knobs, I want to actually do the more fun task, which is setting up that really cool visualizer. It's more difficult, but it's super fun, so I really want to get started on it. So let's create a new function, which we're just going to call draw visualizer. Whoops, draw visualizer. There we go. And in this function, the very first thing that I want to do is request an animation frame with the exact same function. What this is going to do is set up essentially a loop where it's going to loop through at about 60 frames per second our function draw visualizer, and it's going to constantly update the visualizer for all the new different audio forms. So when we play a note, you can see the updates in real time, and it's just going to loop through this essentially infinitely because we have no way to break out of it. And that's okay. We want the visualizer to be there permanently, always updating as long as the user's on the page. Now inside of here, we need to do a little bit of fancy work to get out the different frequencies of our audio context. So right now we just have a context. We don't have any way to get the information from it. We need to create what's called an audio analyzer. So let's just come in here. We'll create, an analyzer node. So we'll say analyzer node equals new analyzer node. And we need to pass it in the context that we're using to create this. And we can also pass in some options. And I want to pass in the option FFT size. And we're going to pass 256. And this number is essentially how many different frequencies you want to control. If you pass it a really large number, you're going to have very small frequency ranges, which means you're going to have a lot of different frequencies that you see in your graph. While with a larger number, it's going to consolidate the frequencies into larger bands. So, maybe from 10 dB to 50 dB in this scenario, or if you had a number of like 1,000, you would now have 1,000 discrete measurements. So maybe it would only go from 10 to 20, for example. And I can show you the difference when we actually start visualizing and drawing out this graph. But 256 works really well because it's large enough that it is visually appealing, but it's small enough that you can really see changes in your different frequencies. So now inside of our draw visualizer, we have this analyzer, and we need to connect it first to our context. So inside setup context, let's just do our connect. So right before our destination, we can just say connect analyzer node. So now we're actually analyzing the information of the audio coming from our audio context. And in here, what we can do is actually get that frequency information. So we're going to say buffer length is equal to analyzer node dot frequency bin count. And this is going to essentially give us a number for how many different frequencies we're going to be measuring. The next thing we're going to want to do is to create an array. So we can say data array is equal to a new, and we want this to be a uint8 array, because it's just going to be 8-bit unsigned integers that are going to be returned to us. So we have our data array, and we want it to be the same length of our buffer right here, because this is how many different frequencies we're getting from our analyzer node. And then finally, we can populate that array, because right now it's an empty array, by saying get byte frequency data, just like this, and we pass it in our data array. So now this array is essentially populated with the value that corresponds to how loud that particular frequency is, and this frequency bin count determines how many different frequencies we are actually measuring. So now what we can do is actually draw this on our canvas. So we need to get the width and the height of our canvas, which is just equal to visualizer.width. And we can do the same exact thing down here for height. That's going to be our visualizer height. And now we need to determine how wide each one of the bars in our visualizer are going to be. So we can say bar width. And this is actually fairly straightforward. All we need to do is take the width of our entire graph, in our case, the width of our visualizer, and we're going to divide it by the number of, different frequencies we have, which is our buffer length. This gives us an evenly segmented number, so we can see exactly how many frequencies there are. And if we increase our frequency bin count by updating this FFT, we'll have, a smaller bar width, or if we decrease it, we'll have a wider bar width to make sure it fills the entire space. And again, I'll show you that in a little bit once we get the frequency, visualizer up and running. Now, the very last thing we need to do is actually get our canvas. So we'll say our canvas context is equal to visualizer.get context. We're going to be getting a two-dimensional context, so we'll pass in 2D here, and then all we want to do is just clear it. So let's say canvas context.clear rect 0, 0, width, and height. So this is going to go from the bottom top corner, the top left corner, and it's just going to draw a rectangle clearing out this entire canvas, which is exactly what we want. Now we can loop through our data array and just say for each item, and we're going to get the index as well, because we're going to use that instead of our calculation. Now what we can do is draw each one of our frequency bar graphs. It's essentially just a vertical rectangle. And all we need to do is get our top Y position. And this top Y position is going to be equal to our item, which is our frequency essentially. That's this right here inside of our array. It's the strength of our frequency. And what we want to do is we want to divide that by 255. That's going to give us a number between 0 and 1, because 255 is the maximum value for our frequency and 0 is the lowest value. So this is going to give us a value between 0 and 1. And then to scale that to the height of our document, we can just multiply that by our height. So this is going to draw a bar from either the very bottom of our page all the way up to the very top of our page. But we don't want a bar that tall. We only want the bars to go halfway up our page. So we can instead divide by 2 here. and that's just going to have our height, so the max height of our bar is going to be half the height of our page. Now to get our X position, this is actually pretty easy. We just take the width of each individual bar and we multiply it by the index that we're currently on. So if we're on the 10th value, it's going to be 10 times the width of our bar, which essentially moves us over 10 bar placements. Pretty straightforward. Now we can actually draw this. So we can say canvas context.fill style. This is going to be what color we do. For now, I'm just going to print out all of these as black bars, so we'll just do RGB 000. Just for now, we're going to change it to make it super cool and colorful in a little bit. I just want to get it on the screen. Now to actually draw this, we'll do a fill rect. It's going to start at our X position. That's like where our X is going to be. And our Y position is just our height minus our Y, because we want it to be the bottom half and not the top half of our graph. So if our Y was 0, for example, it would be all the way up here. But when we subtract that from our height, we're going to be pushed all the way down here, which is exactly what we want. Now we're going to determine the width of this, which is just going to be our bar width, and the height of this, which is just our Y element here. So now with all of that done, we're drawing out our elements. We can click save and see if this actually works. And of course, it's not going to do anything yet because we need to call our draw visualizer function. We'll just call that up here, click save, and there you go. We can see that we have our graph being drawn out. I can play a note on my guitar, and you can see that it draws that out. Play a higher note, and it looks a little bit different. So we know this is working, but you'll notice that A, it's super fuzzy, and B, it's entirely black, which looks pretty terrible. So let's first fix this black color and then move on to fixing the fuzziness, because this black color is really easy to fix. All we need to do is use HSL, and inside of here, we're going to have some kind of value here. Then we're going to have 100% lightness and 100% saturation, 50% lightness. This is going to give us like the brightest color possible. And then here, for our actual hue, what we need to do is determine how tall our bar is, and the taller it is, the more we're going to shift the hue. So a super low bar is going to be red, and then we want to shift up to some bluish purpley color up here. And if you remember correctly, hue goes from 0 to 360, where 0 is red, and then you go all the way through all the colors back to 360, where it is again red. So we don't want to go from 0 to 360, we want to go from maybe 0 to 200. 200 is like a bluish color, so that'd be a good stopping point. So what we can do for that is we just take our Y point and we divide it by our height. This is going to give us essentially a value which is proportional to the height of our screen. So if Y, for example, is 50 and our height is 100, this is going to give us 0.5. And then all we need to do is multiply this by that constant of 200, which is going to be our maximum value possible. But if you remember correctly, we divided our height by 2 here. So essentially all we need to do is re-add that 2 back in so that we can go from 0 to 200. So instead this could just be, 400, because that's what 200 times 2 is. So this is going to give us a hue between 0 and 200 for a value, and that's going to give us either red all the way up to blue. Now if I save immediately, you can see we get those really cool looking colors where it's blue as it's towards the top here, and we got green and yellow and red as we go down. So if I play a note here, you can see we get that nice blue, and I can play a higher note and you can see, that makes the frequencies that are higher up actually move. Now for fixing this fuzzy look that you can see, it's kind of got this fuzzy, not quite perfectly crisp look, we're going to create a function called resize, which we're going to call every time we resize our screen. And all we need to do is take the actual width of our context and we need to set it. So right now we have the width of our context being set in CSS, but we're not actually setting it on our canvas itself. So here we're going to set the width equal to the CSS width, which is just our client width. That's going to be the actual width of it on our screen. And we need to multiply that by window.device pixel ratio. So this is going to make sure that if you have a screen that is really high in pixel density, it's going to take into account that pixel density. We could do the exact same thing for our height. So we can come in here and say height, and we can say that this is going to be our client height. And now if we save and make sure that we call this resize function, we'll just do it all the way up here. Resize. You can now see that this looks much crisper than it was before. So I'm just going to clear that out. You can see it's got a kind of fuzzy look to it, and now when we add that back in, it has much crisper looking bars, which looks way better. It may be a bit difficult to tell the difference on YouTube, but I can assure you, looking at it in person, it is a massive difference. And now with these bars here, let's actually take into account what it looks like if we increase or decrease this number. Let's just say we had a really low number. For example, we're going to have this number, so we're going to go to 128, and we save. You now notice our bars are twice as thick as they were before. So we have wider bars, which means they encapsulate a larger frequency band, and it's kind of more of an average, as opposed to if we increase this drastically. For example, let's say we go to 1024, that's about 4 times as large, and we save. You can see we now have very small frequency bands. And something cool about this is if I play a note on the guitar, you can see that it kind of spikes up different points along the line, and that's because a note is actually just a wavelength, and it's popping up all the different points where that wavelength actually meets inside of our frequency band. So you think like a sinusoidal wave, it's actually showing that inside of these wavelengths because we have such granularity. But generally when you have a visualizer like this, you don't really want that granularity. So this 256 looks much better. It smooths things out and it looks really good overall. So now the next step is actually going to be one of the easier ones for our application, and that's going to be setting up the event listeners so that all of these different knobs do something. And the very first event listener I want to set up is actually going to be an event listener that's associated with this resize function, because right now we only resize once, but what happens if I change our browser size? Like this, for example, it's going to make this slightly blurry because it doesn't quite have the correct width being set. So what we need to do instead is set up an event listener for that. So we can just create a function called setup event listeners. There, whoops, I cannot spell, there we go. And inside of here, the first one we'll do is window.addEventListener for resize, and we're just going to call that resize function. So now no matter what we do with our application, whether we make our window very wide or make it very narrow, it's going to make sure that these elements are perfectly crisp at all sizes. And that's exactly what we want. Let's just make this a little smaller so we can actually see all of our code. Now the next thing to do is we're going to do our volume knob. So we can say volume.addEventListener on input. That's going to occur anytime that we change our knob. And we want to just call this, and all we need to do is convert this to a float. So we can say const value equals parse float of e.target.value. This is going to take that string value of 0 to 1, convert it to an actual float number so we can use it in our application. Now the next step is to actually change the volume of our audio context up here. In order to do that, we need to create something called a gain node. This is essentially how you change the volume. And we can set our gain node, pass it in our context, and for our default gain, we're just going to pass in our volume.value, just like that. So now inside of here, we can say gain node.gain.value, and we can set it equal to our value. Now in order to get this to work, let's just call setup event listeners. And let's make sure that inside of our setup context, we apply that gain node. And we want to do this before our visualizer so that all of our changes to our gain, our volume essentially, are visualized in our visualizer. If we do the visualizer before, it won't actually pick up on the volume changes. So now if we save that, you can see that if I change the volume, this visualizer is changing at 0. Obviously it's 0. And as I go way up here, you can see that now my visualizer is peaking much higher and here it is peaking much lower. And you'll notice though a slight problem. If I play a note, you may hear some popping or clicking sounds when I change the volume. I'm not sure if you heard any of those clicking or popping sounds, but one issue is if you change your value drastically between one value and another value in a short period of time, the computer essentially has a hard time of making that jump. So it, sometimes has a pop or a click to get to that new value. But luckily, you can actually fix that really easily by calling a function here called set@targetTime. We give it our value here, which is where we want to be. We give it our start time, which is just our current time or our context. Then we give it essentially a change value, so 0.01. So what this is going to do is give us a nice smooth change of our volume, and it's not going to give us those weird clicking sounds. So again, I can change, I can play a note here, and if I change my volume, hopefully you don't hear any clicking sounds. And you may not have heard any before, and it was just, dumb luck that it didn't happen, but doing this is going to be much better at making sure you don't have any weird clicking or popping sounds. Now with that done, let's move on to our next section, which is going to be setting up the bass. So instead of volume here, we're going to add event listener for our bass, and we want to make sure we parse this to an integer because we know that this is always between -10, +10, and it's always going to be an integer. But instead of setting our gain node, what we need to do is take our base EQ. We'll just call it base EQ. And this base EQ is going to modify the EQ, essentially the volume of different frequencies. So up here, let's create that base EQ. And this is going to be equal to something called a biquad filter node. We'll pass it in our context, and here we specify all of our different options. So for our base, we want to modify our very low frequencies. So we can set a value of our frequency to 500. And by default, this doesn't do anything on its own when you just set this to 500. You also need to specify a type. And in our case, we want to do everything underneath the frequency 500. So we use a low shelf. What this does is it modifies everything under the frequency 500. And gain is just going to be essentially how much we increase or decrease that by, which is just the value of base. So we'll say base.value here. So now if I save this, Make sure down here we apply our bass. We'll just put it all the way up here. So we'll connect our bass EQ. Now we hopefully should be able to see changes in bass. If I max this out, you should hopefully see the bass section increase. I'll play a note. And when I decrease it, you should see that decrease. This did not really make any noticeable change though, so obviously we have an error. Let's just see if we do. In our console, you see we have uncaught reference bass EQ is not defined on line 31. Looks like here I just spelled bass wrong type of bass there. So now let's make sure we don't have any errors. Nothing in the console. So now if we change this bass and I lower it by a bunch, you should see these bars are lower, so I'll play a note. And as I increase the bass, you should see it increase. Just like that. So now we're able to modify those bass frequencies. We saw this bottom section increased and decreased as I changed my bass slider. Let's do the exact same thing, but we're going to do mid, for example. And this is going to be a mid EQ. And down here, we want to make sure we have our mid EQ. And mid is actually going to be slightly different than bass in the way that we set this up. It's going to be similar, but a little different. We're using the same biquad filter node. Our frequency here, we'll just use 1500 as a nice value. We want this to be our mid value. But instead of doing a low shelf, because we don't want to do everything under it, and we can't do what the opposite of a low shelf is because we don't want to do everything above it either. We want to do kind of a range around this 1500. And that's what something called peaking is used for. So peaking essentially says we're going to have a peak and it's going to raise up at this 1500 and slowly die off until we don't have any further change at all. So it's going to kind of have a range that it's going to do between 1500, same on both sides, where it's going to increase or decrease our volume. And to determine how far that range spreads out, we use a factor called the Q. And essentially, the smaller you make this, the larger your range is going to be, and the quicker you make it, the harsher it's going to drop off, and the shorter that range is going to be. So for us, we're just going to use a nice value here of math of square root 1/2, so it's a square root of 0.5. This is going to be a nice and small number that gives us a large enough range without overlapping in our bass and our high sections too much. So now, hopefully, we should be able to see this take effect now that we have everything set up. Let's just, again, make sure we have no errors, nothing in the console at all. So now over here, whoops, not treble. What we can do, I'll play a note. Now we can change our mid, up and down. You should see it make a little bit of a change in this section down here. There we go. So now the very last thing to do is essentially the exact same thing, but with treble. So copy this down one more time, but instead of mid, we're going to have treble. And instead of mid EQ, we're going to have our treble EQ. And we're going to add in our treble EQ here. And up here, I'm going to copy this bass one because bass and treble are almost exactly the same. The only difference is that this is going to be a high shelf instead of a low shelf. So it's going to be everything above a certain frequency. And we obviously want to have a larger frequency of 3000, for example, and change our treble value. Now, hopefully, if we did everything correctly, let's inspect. Console looks good. If I come over here, I'll play a note, for example. And it's a little bit harder to see. I'll try it one more time. But you can see kind of these frequencies over in this section, they'll raise up and lower down just a little bit. You see a minor change. It's a little bit harder to tell for sure, but it's definitely making a difference. And that's all it takes to make this awesome visualizer / amplifier inside of your.
Okay, so before we take a break and then go to lab time, let's chat about that for a minute. Okay, so some of you might be thinking, man, I don't play the guitar or any instruments. I don't know anything about instruments. Everything he was saying is just totally over my head. Well, you have a voice, right? And he mentioned you do a voice changer app, right? So you might look into how to tweak it for that if that makes more sense to you. But with that ability, what other kind of stuff could you do? Any thoughts after watching this tutorial? What sort of stuff could you do to build on this? Any ideas? There's a bunch of things you could do. Just any thoughts? I just mentioned one of them.
Well, I mean, in regards to like the audio stuff, I don't know. Maybe you could make like a music enhancer if you want to like boost the bass or boost the bass. Or
Maybe.
Equalizer or whatever. So.
Yeah.
Yeah.
Yeah. Anything else? What if I make a mobile game and I want to turn the volume up and down in my game or my app, right? What if I want to build a physical guitar amp right? And put an Arduino in there and tie knobs and buttons to those features. Could I do that? Absolutely, I can. They'd just be keyboard presses, right? And things to that nature, right? So we could definitely do that. There's a bunch of different things. Now that's just one of the many, 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 many ways that you can do a web, the web audio. Next time, we're going to learn how to build a piano using JavaScript. It's actually a much shorter video, but just thought I might keep it kind of musical this week. And then next week, we'll try to get back into the games and other types of applications and stuff like that. As I often say, obviously, no one has mastered JavaScript yet. But by and large, is everybody feeling okay or decent about JavaScript? Or at minimum, do you feel that you can watch a video or listen to me lecture or something like that, and the concepts are kind of clicking and making a little bit of sense? Is that kind of maybe, possibly? Now, this class, this semester, we will have a certification exam for JavaScript, okay? And it's my hope that I will have exposed you to enough different uses of all these different things, like constants, and how to do loops, and how to do all the different things that come in the JavaScript API, essentially, right? That you can do audio sources and all these different things. That hopefully I'll have shown you enough different ways to use all those different things that the concepts will have sunk in, and you'll be able to pass a certification exam. You need 70% to pass, and I have full faith in everybody's ability to do that. Any questions, concerns, comments, thoughts, or ideas? Alrighty, come back at 10:15 and we will start working on actually building that guitar amp thing that we just